So we completed the molarity, right?
Yes, sir.
Yeah, we just started the molarity in the last class. So I'm going to give you some questions on this and then we will move on. So molarity is a formula number of moles of solute upon volume of solution in liter. So here the gives 49 gram of H2SO4 present in 250 centimeter cube of solution. Calculate molarity. Please do this easy question.
For centimeter cube, how do we convert it into liter?
It's just like 1 centimeter cube is equal to 1 milliliter. So basically, if you want to convert milliliter into liter, you need to divide it by 1000, right? You will get the liter. So in the same way, if 1 centimeter cube, if you want to convert it into liter, it will be divided by 1000. Okay.
Okay, sir. Sir, the answer is 196.
196 what? How did you get 196? What is the unit? It's very important. 196 what? Whenever you are finding something, please do it with the units. Okay, let's say molarity. We need to calculate molarity. First of all, whenever you are going to calculate, you need to write whatever is given. It's given like mass of H2SO4, which is a solute, is given 49 gram, and volume of solution, which is given 250 centimeter cube. And you can easily convert it into liter, 250 by 1000. So you can say it is 1 by 4 liter, right? You can easily cancel this 4 times. Now, what we need to calculate is molarity, and molarity is equal to number of moles of solute, number of moles of solute upon volume of solution in liter, right? Upon volume of solution in liter. Yes or no? Now you can see we need to volume of solution in liter is here, but number of moles of solute is not directly given. So we can calculate number of moles of solute. Solute is H2SO4. So number of moles of solute will be equal to given mass upon molar mass. So this will be the given mass 49 gram and molar mass is, what is the molar mass that you have calculated for H2SO4, Sakina? Sakina, what is the molar mass?
Sir, molar mass of
H2SO4.
sir, H2SO4,
Yeah,
it's 98.
98. So you got the value of number of moles of H2SO4. That is equal to half moles, right? Now, as you can see, now I'm going to put the value. Molarity M is equal to number of moles of solute that we just calculated 1 by 2 moles, and volume of solution we just calculated 1 by 4 liter. And after solving it, you will be getting this moles in numerator and liter in denominator. So you will be getting 2 moles per liter, or either we can write 2m. How did you get 1 by 96? Where you have mistaken.
Sir, I didn't convert the 1 by 2 moles. I use it directly
You
as
just
149.
149?
Sorry, 49.
49. Before putting the value, just see what is this 49. 49 is gram. 49 gram, that means mass. And in formula, you have to keep the value of number of moles of solute. Are you getting my point?
Yes, sir.
Okay, so please do write it and let me know.
Sir, done.
Very good. I'm going to give you another question. Given that 7.1 gram Na2SO4 present in a solution of volume 500 ml, calculate molarity. Anushka, am I audible?
Yes, sir.
So we started this molarity, questions on molarity. You know the formula of molarity. In the last class, I had explained the formula. Please do solve this. And if you are unable to do it, just let me know.
Sir, for ml, if you have to convert it in liters.
Yes, in the formula, you can see volume of solution in liter. So when you are going to calculate molarity, you have to convert it into liter. Okay.
Sir, the same like last time, 1 divided by 1000.
Yeah, you have to remember this conversion. Okay. You know 1 liter is equal to 1000 ml. Yes or no?
Yes, sir.
So 1 ml is equal to 1/1000. From milliliter to liter, you need to divide it by 1000. From centimeter cube to liter, you need to divide it by 1000. Same.
Sir, the answer is 0.1.
0.1. Okay. Let me check. So it's given that the mass of Na2SO4 is 7.1 gram and volume of solution is given 500 ml. So we can write here mass of Na2SO4, that is given mass is 7.1 gram and volume of solution in liter. Volume of solution is 500 ml, which you can easily convert it into liter by dividing by 1000 and you will get half liter. And in formula, you know molarity is equal to number of moles of solute upon volume of solution in liter. So you can see this is the volume is directly given, but you need to calculate the moles. This is mass. Mass is given. So number of moles of Na2SO4 is given mass, that is 7.1 upon molar mass, that is, what is the molar mass that you have calculated for Na2SO4? Sakina and Anushka.
Sir, same,
Sir,
sir.
one
7.1.
Can you repeat it again, Anushka? Sakina, can you repeat?
sir, or 142.
Yeah, it will be 142. Very good. Now you can see if you're going to remove this decimal, there will be multiplication of 10 in denominator, and this will be cancelled by 2 times. So we will have 1/20 moles. Now I'm going to put this value in this formula. So what is the number of moles of solute? That is 1/20. And what is the volume of solution in liter? It is 1/2. So you will be getting 1/20 into 2/1. That means basically you will get 1/10. That means 0.1 moles per liter. This is the unit of molarity, or either you can write directly 0.1 capital M. This capital M stands for molarity. Very good, Sakina. Uh, Anushka, are you done with this?
Yes, sir.
Okay. Now I'm going to give you another question. Please do it. Are you done with this? Sakina? Anushka, what about you?
No, sir, not done.
Okay, see, I'm going to explain. What does this mean? 10% weight by volume. I already told you when we were learning weight by weight percent, volume by volume percent. This is your 10. Since it is weight, so we are going to take 10 gram of numerator, that is basically for solute generally. So 10 gram of solute, and here solute is CaCO3. So I'm gonna put it here in a bracket. 10 gram of CaCO3 or so 10 gram of solute present in, since this is your percent, so 100, And in numerator, you can see this is your volume. So it will be ml, and the denominator, this denominator is for solution. So 100 ml of solution. So from this, you just extracted a full sentence, which will give you information like 10 gram of solute, that means mass of solute, that means CaCO3 is given as 10 gram. And also volume of solution is given as 100 ml. Now you can see, if you're going to apply the formula, molarity is equal to, it is equal to number of moles of solute upon volume of solution in liter. Again, you can see we need to keep the value of put the value here of number of moles of solute, but mass is given, but we can calculate easily. Number of moles of CaCO3, that will be equal to given mass upon molar mass. Given mass is 10 gram, and molar mass, if you are going to calculate for CaCO3, it will be 100, and you will get number of moles as 1 by 10 moles. And volume of solution in milliliter is given, so you can easily calculate it or convert it into liter, and it will be again 1 by 10 liter. Now I'm going to put the value. What is the number of moles of solute? That is 1 by 10 moles. What is the number of volume of solution in liter? That is 1 by 10 liters. So this and this number will be cancelled, and here you will get 1 mole per liter or 1 m. Sakina and Anushka, is there any doubt in this?
No, sir.
No, sir.
Understood.
Please do write it and do solve the D part. Let me know the answer. Are you done with the B part? Sakina, are you done with this?
Sir, doing.
Okay. What is the number of moles that you have got? Anushka, are you done with this? Now say it's given that 4.9% weight by volume H2SO4, right? We need to calculate molarity. And here you can see it is. What does this mean? 4.9 gram of solute present in 100 ml of solution. 100 ml of solution. Now from this statement, you can see given mass is given, mass of the solute given, and volume of solution is also given. So we can easily go for molarity now. Molarity is equal to number of moles of solute upon volume of solution in liter. Now, if you are going to calculate number of moles of solute, that will be equal to given mass, that is 4.9, upon molar mass, that is 98. You can easily say if you are going to remove this decimal, there will be 10 in denominator. and it will be cancelled by 2. So you will get number of moles as 1 by 20 moles. And you can see the volume given in ml. So you can convert it into liter by dividing it by 1000, and you will get 1 by 10 liter. Now you just need to put the value. Number of moles of solute is 1 by 20, and number of volume of solution in liter is 1 by 10 liter. This is your moles, this is your liter. So you can see 1 by 20 into 10 by 1, and it is mole per liter, moles per liter. So you can easily calculate it. It will be 1 by 2, that means 0.5 moles per liter. Or you can either write 0.5. Is it tough? You are taking too much time, both of you, Sakina and Anushka. What was the problem? Where you have stuck?
Sir, it just takes time in the calculation. Little bit.
Calculation is not that much tough, Anushka. Is it tough, the calculation? What about you, Sakina? What's your excuses about this?
Sir, I get I mess up the formulas and then have to go and then look at it
Very
again
good.
and then do it.
There is a simple formula and you are messing it up. Very good. Everyone done with this? Can I change the slide?
Yes, sir.
If you are going step by step, there will be not any chances for wrong. Let me give you the last. Wait a minute. Mm, 10.6% weight by volume, Na2CO3. Please do calculate the molarity of this. Let me know when you're done with this.
Sir, done.
What is the answer?
Sir, 0.2.
0.2. What is 0.2? 0.2, what is the unit?
Sir, moles.
Moles? What is the unit? Is it moles? You calculated molarity and you are telling me that it is moles. Mole is different from molarity, right?
Yes.
So please do tell me what is after 0.2.
Sir, it's molarity.
Molarity is the name. What is the unit?
M.
M stand for?
Molarity.
Very good, Sakina. M stand for molarity. Okay. What is the unit of molarity?
Sir, moles per liter.
Yes, this is what I want to hear. This is the unit. and this capital M, we denote moles per liter by this capital M, okay? And molarity is the quantity of which moles per liter, or capital M is the unit. Uh, is that clear, both of you? Anushka?
Yes, sir.
Okay. Sakina, have you got also got the value 0.2 M?
Yes, sir, 0.2.
Okay, let's move to the next concept of molarity, and it is molarity on dilution. Molarity. Everyone knows what is dilution? Yes or no?
Yes, sir.
Sakina. Basically, addition of solvent, and in our day-to-day life, as a solvent, we generally use water. So addition of water or addition of solvent, we can call it. This is dilution. See, there is a container in which number of moles of solute is n. N is number of moles of solute. Number of moles of solute. And molarity of this container is M1, and volume of this solution in the container is V1. Now what you are going to do, you are going to add some water or solvent. You added some solvent or water, and since you added water, the molarity changes, and now the molarity becomes M2 and volume becomes V2. Volume changes, that's why molarity also changes. What I want to know is that will the number of moles of solute changes or not? If you are going to dilute a solution, will the number of solute affected or not? It will be constant or it will be changed. What do you think? Sakina? Anushka?
Yes,
If
sir.
you are going to add water in a solution, will the number of solute changes? Yes or no?
No, sir.
No, it will not change. If you are going to have some particles of H2SO4 and you are going to add water, the number of solute will be as it is. The number of moles of solute or the number of solute will be as it is. Now I'm going to derive a formula. Now I'm going to derive this formula. Now you can see I'm going to apply the formula N1, M1 for this container, and it will be number of moles of solute upon volume of solution in liter. N is equal to, it will be M1 V1, and here you can see molarity M2 will be equal to number of moles of solute upon volume of solution. N will be equal to M2V. Now as you can see in both equation, M1 V1 is equal to N, that is number of moles of solute. M2 V2 is equal to N, that is number of moles of solute. Both are equal to each other because N and N are same. So this is the formula that we have got. M1 V1 is equal to M2 V2. Is that clear?
Yes, sir.
So it's very important to note this is the formula for dilution of a solution if you are going to calculate the molarity. So please do write it. Then I'm going to give you a question on this, and then you'll get it.
Sir, I'm done writing.
Very good. I'm going to give you a question. Sakina, are you done with this?
Yes, sir.
Okay. Wait a minute. Please apply the formula. If you don't get it, just let me know. Let me know if you are unable to solve it.
Sir, it's 0.3.
0.3. Just let me check it. So see, this is your M1 and this is your V1. And what is your V2? Since you can see this is your container in which molarity is 0.5 m and volume is 200 ml, and you added 100 ml solvent or water, that is. So what will be the final volume? It will be 300 ml, right? And we need to calculate M2. So M1 V1 is equal to M2 V2. And you just need to put the value. M1 is 0.5 and V1 is 200 and M2 is, we need to calculate, and here it will be 300. What you have taken the value of V2? Tell me.
Sir, can you repeat what you said?
What is the value of V2 that you have taken?
Sir, V2 is 300.
Yes, very good. Then it is correct. You can say 0, 0. 0, 0 will be cancelled. 5 into 0 0.2, that is equal to, that will be equal to 0 0.5 into 2. 1 it will be equal to, and here it will be equal to 3 into M2. So M2 will be equal to 1 by 3. So it will be 0 0.333. Anushka, are you done with this?
Yes, sir.
Okay. You have any doubt?
No, sir, no doubt.
Okay. Now moving to the next, that is third type of molarity, and that is molarity of mixture. In the previous one, we did dilution, that means addition of solvent. But here mixture, we are going to mix two solution. You can see here the number of moles of solute is N1, and here the molarity is M1 and volume is V1. There is another container which has number of moles of solute N2 and molarity M2 and volume V2. Now you are going to mix these two solutions together, and it will be a new M and volume V. Can anyone tell me what is the value of V? V will be equal to V1 plus V2, because whatever is the volume present here and here, you just mixed it. So the final volume will be equal to V1 plus V2. Yes or no? Anushka and Sakina. Anushka, Sakina, am I audible to both of you?
Yes, sir.
Yes, sir.
So whatever I told, I just told her, have you understood? Why V is equal to V1 plus V2?
Yes, sir.
Now here the number of moles of solute is n, and just take the number of solute present in the bigger container will be the sum of number of solute in these two containers. Just take 5 moles of solute is here and 5 moles of solute is here. So what will be the number of solute present in here? It will be 10, right? Now again going to apply the formula here. M1 will be equal to N1 upon V1 and N1 will be equal to M1 V1. And here you can see M2 will be equal to N2 upon V2 and N2 will be equal to M2 V2. And again, if you are going to apply this formula on here, M is equal to N upon V and N will be equal to M into V. Please do write up to this, then I will go ahead. Let me know when you're done with this.
Yes, sir, done.
Very good. Now, you have seen that I had written in the bigger container n is equal to n1 plus n. What is the value of n? M into V. This capital M stands for resultant molarity. That means molarity of mixture. N1 has a value M1 V1 and N2 has a value M2 V2. Now, the molarity of mixture will be equal to M1 V1 plus M2 V2 upon V, or either we can write M is equal to M1 V1 plus M2 V2 upon what is the value of V? V1 plus V2. Let me know when you are done with this.
Yes, sir, done.
Very good. Now I'm going to give you a question. 0.2 m, comma 250 ml HCl mixed with 0.1 m, comma 500 ml HCl solution. This is also HCl solution. Calculate molarity of mixture. Are you done with this?
No, sir, almost done.
Are you done with this? See, I'm gonna explain you. Have you solved it yet or not? Anushka and Sakina. Anushka, you are not audible. This is your M1, this is your V1, this is your M2, this is your V2. And since it is mixed, so molarity will be equal to M1 V1 plus M2 V2 upon V1 plus V2. What is M1? 0.2 into V1, 250. Plus what is M2? 0.1 into 500 upon what is V1? That is 250 plus 500. V2 is 500, so you just need to calculate it and you will be getting this. This decimal will be cancelled, 0.2 and it will be 50 plus 50. Upon now it will be 750. So 100 divided by 750, 0.133. Sakina, what is the problem where you have a stub? Sakina, are you there? Anushka,
Yes, sir.
please do write it and then let me know.
Sir, your voice is lagging.
Is my voice lagging again?
Sir, it's fine for me.
Yeah. Sakina, your voice is lagging. Sakina, am I audible clearly? Please do write it and then let me know.
Done, sir.
Okay, I'm gonna change the slide. Now moving to the last part of this molarity, and right, this is your molarity of ions. And we are going to understand this concept with the help of an example. Let's say we have 49 gram of H2SO4 in 250 centimeter cube of solution. Calculate molarity of first H2SO4, that means solution. The B is ions, that means H plus, and the C is SO4 minus 2 ions. Now see how we are going to calculate. Whenever you need to calculate the molarity of ions, first you need to calculate the molarity of the solution like this. The normal formula we are going to apply. Molarity will be equal to number of moles of solute upon volume of solution in liter. Number of moles of solute you can see is given mass 49 gram. Number of moles of solid 49 upon 98 is the molar mass, and volume of solution is 250 centimeter cube divided by 1000. So you can easily cancel it and you will be getting 1 by 2 here, and here you can see you will be getting 1 by 4. Now you can see it will be 1 by 2 into 4 by 1. That will be equal to 2 moles per liter. This will be cancelled by 2 moles per liter. So it's very easy till this. Now, how we are going to calculate the molarity of ions? So after calculating this molarity of the solution, what you need to do? Dissociate this H2SO4 into its ions and balance it. You can see H2SO4 will give H plus plus SO4 minus 2, and in order to balance it, there is 2 hydrogen here, so we are going to multiply it by 2. Is that clear, Anushka?
Yes, sir.
Now you can see what is the what is the coefficient here? What is the stoichiometric coefficient here? 1. What is the coefficient here? Stoichiometric coefficient 2, and here 1. In class 11th, you have studied the stoichiometric. That means basically 1 mole of this will give you 2 mole of this and 1 mole of this. Is that clear? Is that clear? The coefficient decides. First of all, write up to this part, then I will explain. Okay, please do write up to this part. Are you done with this?
Yes, sir.
Okay. Now see. After calculating the molarity of this, you can see you got 2 moles per liter or 2m. So first we are going to compare it with the mole. As you can see that 1 mole of this will give you 2 mole and 1 mole of this. In the same way, we can compare the molarity. That means 1 molarity of this will give 2 molarity of this and 1 molarity of this. Are you getting my point? This 1, 2, 2 is comes from here. It's a stoichiometric coefficient. Are you getting my point, Anushka?
Yes, sir.
That means if it is 1 molarity, it will be 1 molarity. You will have 2 molarity of H plus and 1 molarity of SO4 minus 2. But we have 2 molarity of H2SO4 as you can see. So if this is 2 molarity, then H plus, you can see if you have 1, then you get 2. So if you have 2, you will have 4M. And if you have 1, you have 1, then 2, then 2. That means basically molarity of H plus is 4M and molarity of SO4 minus 2 is 2M. Is that clear? What you need to do is to calculate molarity of H2SO4 or whatever is the solute given, and then dissociate it into ions and compare their stoichiometric coefficient. Then you will get your answer. It's unitary method. Please do write it. Then I'm going to give you a question. And if you have any doubt in this, just ask me. Are you done with this?
Yes, sir.
Okay, I'm going to give you another question. 71 gram Na2SO4 in 250 ml solution. Calculate molarity of first Na2SO4, then Na plus, and then SO4 minus 2. Please do it. See, I'm gonna explain. Have you calculated the part one? Sakina? Anushka? So molarity of Na2SO4, that will be equal to given mass upon molar mass. Given mass, sorry, no, number of moles of solute upon volume of solution in liter. Now I'm going to put the value of number of moles of solid, that is given mass upon molar mass and volume of solution in liters. So we are going to divide it by 1000, and you can see there you will get 1/2 and here you will get 1/4. So indirectly you will be getting 4/2 m, that means 2m. So you got the molarity. Now you just need to dissociate this into ions. So it will be Na plus and sulfate ion, that is SO4 minus 2. So there will be 2 multiplying so that it will be balanced. Now you can see 1 molar